Over the next few minutes you'll observe how Edgecam generates toolpaths in the mill turn environment and how this part is reversed in readiness for the second-hand machining. Let's take a moment to inspect some of the features which are currently on view. The CAM instructions are clearly displayed down the left-hand panel. Using the workflow steps, I will later show you how these toolpaths are created. First of all, let's move into the machine simulator. This is supplied as standard and allows the user a clearer understanding of the shape of the toolpaths. It will report potential collisions between the stock, tooling and even the machine tool. Here we see the rough profiling cycle, which is ideal for maintaining tool contact whilst using the stock to clip back the toolpath. Now we see a V&MG insert using finish turning. And next, a drilling cycle, where we'll use the simulator's clipping command to gain a better appreciation of the toolpath. This is very useful for internal bore features. There are multiple options for pausing the toolpath. For instance, stop at collision. If a fault is detected, Edgecam will inform us. So, our toolpaths look okay and we've detected 0 collisions. Thus with confidence we can now produce the CNC program. Simply select the Generate Code button, the CAM data is passed through the post processor and automatically the program is displayed in the Edgecam editor. Another useful tool is Live Job Reports, which automatically create our shop floor documentation. This is a live document which can be viewed on any internet enabled device. The tooling is displayed. And next, the CAM instructions. The document provides invaluable information while setting up the part. And lastly, images of the machine setup can be inspected by the setter operator. As the cursor moves over each CAM instruction, the associated toolpath is clearly highlighted. A double click allows the user to edit the command. Here we see a typical tool. This has been summoned from the tool store, which again is standard. It's very simple to create any type of tool because we use the ISO definition. Next we'll see the rough profiling cycle, ideal for hard materials made from castings and forgings. The toolpath constantly follows the profile and uses the stock. One of the most common cycles is rough turn. Observe how pictures inside the dialog help explain the effect of the command. Similar to other Edgecam cycles, rough turn is aware of the stock position, thus helping to reduce fresh air cuts and maximise efficiency. And speaking about stock, you'll notice that as I edit another CAM instruction, the stock image is reversed, representing the stock condition at that stage of the machining. So now, from a practical point of view, we now need to reverse the component to produce toolpaths for the second end. The stock on this part is a forging which is automatically transferred, so I don't need to actually create stock in this instance. I'll select Create Sequence command. Down left hand panel I'll pick the post processor and also a toolkit. Automatically Edgecam creates a datum or CPL detecting the Z extent of the solid model. I'll now put the part stick out. This determines the protrusion of the workpiece. And now I can either allow Edgecam to automatically detect the stock diameter, or in this case I'll manually enter a value. Observe how the component is reversed in the chuck, plus the stock profile is updated. Following the workflow stages, I will now feature find. Here, Edgecam creates machining features directly from the solid model. Again, you'll observe that pictures and dialogues are used. Feature Finder will detect the specific sizes of the external thread. Its specification will be later used by the machining command. The features are displayed down the left hand panel. Unwanted features can be dismissed to a recycle bin. You may launch the Feature Finder as many times as you wish. The next workflow stage is machining, and where Edgecam offers 3 levels of creating toolpaths: automatic, semi-automatic and manual. Semi-automatic is achieved through Machine Feature, which allows a user to randomly select features, producing the toolpaths for either roughing or finishing. Automatic machining is achieved through the planning board. Here, the suggested method of machining the part is displayed. A user may choose to delete some of the processes, regarding them unnecessary for this particular part. You'll notice how the planning board moves up when each process is taken out. You can delete as many processes as you wish. Moreover, processes can be reordered by using drag and drop. This is safeguarded, meaning you cannot machine features in the wrong order. You cannot tap before you drill. And once the order has been completed, you may now press Apply. Edgecam's intelligent machining engine now goes to work creating the CAM instructions. Best practice methods are deployed. Tools are automatically chosen from the database as Edgecam can see the size and characteristic of each and every feature. This is why solid models are so important to our process. So in less than a minute, over 40 CAM instructions have been created. Remember, CAM can also be created manually. As you may recollect from first end machining, our final stage of workflow is NC code. When I now select Machine Simulator, Edgecam will detect multiple sequences and simply ask which sequence is to be viewed. I will select second end. We can activate Stop at Collision and now observe the toolpaths, safe in the knowledge that Edgecam will stop and display any issues. You'll notice the CAM instructions on the left hand panel are being simulated one by one. We appear to have 0 collisions, thus we can move on. A user can edit any of these toolpaths. Simply double click and now we can see the finished turning cycle. Moving further down, we can edit one of the milling cycles. Here we see the roughing cycle, which is using one of the best toolpaths known to the CAM market, waveform. Lastly, we see the chamfering cycle, which has been used to remove the sharp edge from the milled hexagon shape. Let's change the tip offset. It's possible to swap the solid model without breaking the toolpaths. The model features will be updated and toolpaths seamlessly refreshed. Imagine how much time this is going to save when designers modify the shape. We select Reload and the name of the modified solid model is now selected. Edgecam will highlight the affected features, drawing attention to those that have been updated or removed. I'll now select Accept to acknowledge the changes, and now I'm going to regenerate the CAM instructions. It's taken seconds for us to deal with the design modification. As I rotate the part, you'll notice the 3D cutout on the top of the part. I'll manually machine this particular feature. I'll activate Advanced, which exposes the full suite of Edgecam commands, and I'm now going to go to the tool store and select a 6mm ball nose cutter. Because we're in mill turn environment, the tool mode is set to driven and the orientation is set to radial. Our mill mode is now set to planar, in other words the chuck is static, and now from one of the many mill cycles available I'm going to select parallel lace. I'll inspect the dialog settings, making sure that Pick Solid Face is active. This means I can directly select a solid face without the need for boundaries. This is another time-saving feature offered by Edgecam. I'll follow the on-screen prompt and select the single face. The toolpath is created. It's worth noting that a user can still interact with the first end machining. Simply double-click the sequence and the commands become active. Remember, the stock is being updated between each of the sequences. For best practice, the whole process is placed inside the machine simulator. There's no limit to the amount of sequences which can be selected. Once inside the simulator, another stop option is set. Stop at next sequence. Both first and second end toolpaths are now simulated, pausing for the part turnaround. By being able to simulate all the toolpaths, first and second end, the user is assured that all CAM program data is correct. Remember, we still have Stop at Collision on. The part is now fully machined. Thank you for watching this video of Edgecam 2-axis turning and C and Y milling.